In this project, we are not simply generating sounds or programming another music player. What we are doing is creating a delicate, emotionally intelligent system that understands the subtle relationship between environment, sound, human physiology, and comfort. The purpose of this work is to design a generative lullaby engine that functions as a living digital organism rather than a static audio sequence. The core concept is rooted in the notion that music, especially lullabies, are not passive background sounds, but deeply interactive emotional systems that communicate safety, continuity, and rhythmic connection between nature, the human body, and the unconscious mind. When we think about traditional lullabies, we often imagine soft melodies and repetitive tones meant to calm a baby to sleep. But if we observe closely, the essence of a lullaby lies not in repetition itself, but in the subtle irregularities, the organic breathing between notes, the unquantized timing, the way a human voice trembles slightly, and how those imperfections build trust. A machine-generated lullaby that repeats identically every cycle would quickly lose its emotional authenticity. Our goal here is to bring those imperfections back into the digital space by designing asynchronous, tempo-aligned instruments that move independently yet harmoniously, the same way natural phenomena coexist. Waves, wind, and heartbeat never synchronize perfectly, yet together they form a stable CA-LM-ness. From a psychological standpoint, a baby's sense of security is not triggered by silence but by predictably soft variation. A steady heartbeat, a gentle breath, or the distant hum of the environment signals that the world is alive and safe. Therefore, the ambient layers in this system, the breathing sounds, heartbeats, natural ambiances, and ticking clock, are not simply effects but anchors. They serve as sonic representations of life continuity. A baby subconsciously perceives these signals as reminders of human presence, warmth, and familiarity, allowing deeper relaxation without slipping into alertness. This delicate balance prevents overstimulation while keeping the brain in a safe, low-frequency attentional mode. The pianos in this system represent emotional intelligence. Each of the 3 pianos behaves independently, operating on slightly different time cycles and tonal shifts, symbolizing individuality and diversity within unity. They are not forced to play in mechanical synchrony. Instead, they breathe. Their fade-ins and fade-outs mimic the dynamics of respiration, while their asynchronous entries create a slow-moving harmonic landscape that never repeats identically. This harmonic unpredictability prevents the human ear from habituating too quickly, maintaining subtle engagement without breaking the trance of calmness. In real-world emotional design, this principle is crucial. The purpose of sound is not to entertain, but to create an emotional architecture, a space that supports comfort, presence, and safety. Babies respond instinctively to rhythm and timbre long before they process words. Sound becomes the first medium of communication, and through rhythm and tone, we transmit a message of security. By combining neuroscience, acoustics, and algorithmic composition, this system becomes an intelligent caretaker that understands when to give space and when to softly intervene. From a technical and compositional perspective, the asynchronous but tempo-linked design reflects the natural structure of complex systems. Each instrument, though independent, follows a shared tempo grid. This ensures cohesion without uniformity. The soft stop mechanism is also part of this human-centered logic. Instead of abruptly halting, the sound environment gradually fades away, just as natural sleep transitions are never instantaneous. The gradual fade-out simulates a caretaker gently leaving the room after ensuring the child is deeply asleep. This simple act of sonic empathy represents one of the key ethical principles of emotional computing, the respect for the listener's mental state. The inclusion of sliders for volume, tempo, and timer represents user empowerment. In real-world applications, no single emotional state is universal. Every baby, every parent, every room, and every night is different. By providing simple yet precise controls, we allow adaptation and personalization without requiring musical expertise. These parameters transform the lullaby from a static product into a responsive system. The listener becomes part of the composition process by adjusting the emotional density of the environment. The time-based fade system with a countdown introduces another dimension, the acknowledgement of duration. Sleep is not only about relaxation. It is a journey through physiological stages. As time progresses, the gradual lowering of volume reflects the natural descent from light to deep sleep. The system listens in its own way, by adapting its intensity as time moves forward. The final automatic soft stop ensures closure, mimicking the way human caretakers instinctively lower their voice when they sense a baby is almost asleep. When you examine this system as a whole, you begin to see the convergence of science, art, and ethics. It's not merely a piece of software, but a reflection of human care expressed through code. It demonstrates how programming can extend beyond logic and mathematics into the realm of emotional design. Every function, every asynchronous delay, every fading parameter becomes part of an emotional narrative. This is the future of sound design and algorithmic art, systems that adapt, breathe, and communicate emotional intelligence. In real-world creative technology, such concepts have profound implications. Designing for calmness, trust, and rest requires a fundamentally different approach than designing for efficiency or entertainment. It challenges us to measure success not in performance metrics or volume levels, but in emotional outcomes, reduced anxiety, improved sleep quality, and sustained feelings of safety. This approach can extend beyond lullabies to fields such as therapeutic soundscapes, mental health technologies, ambient intelligence systems, and adaptive environments for relaxation and healing. Ultimately, this project teaches that music technology is not only about automation or data-driven precision, but about designing digital empathy. Through subtle control of randomness, asynchronous timing, and progressive soft dynamics, we can code emotions. The system becomes a gentle collaborator that interacts with human needs rather than dictating them. It reminds us that true harmony is not perfect alignment, but the peaceful coexistence of independent rhythms moving within a shared pulse, the same pulse that connects the natural world, the human body, and the instinct to nurture.